All right, so now we're going to talk about the secant function. The secant function. So y is equal to secant x is equal to 1 over cosine x, right? So we're going to start with the cosine function, which is going to look like this, right? Whenever this is 0, I get a asymptote, right? So let's go ahead and draw the asymptotes in. Okay. Now let's go ahead and draw the function itself. So when cosine x is equal to 1, what is secant x? 1. So, dun, 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 right there, right? Right here, these points, they all share that point. Right? Because when it's -1, it's -1, right? Okay. As x gets smaller and smaller and smaller, what's going to happen to this guy? Bigger and bigger, right? To the point where it gets to 0, I'm going to go an asymptote. So, looks like it's going to look like this. Right? And it's negative here, positive here. Right? What is the period?
1.
1?
Oh, wait, no.
Is it pi? Every pi I replicate myself?
It's like yes and no.
So this is pi over 2, right?
It's
This is 3 pi over 2. So am I replicating myself when I go from here to here? Are they the same?
No.
No, they're not.
No.
So it's from here to here, right? Every here to here I replicate myself, right? So again, it is 2 pi. So the period is 2 pi there, right? Okay, are we good?
Yeah.
All right. But you understand how I drew that, right? So as long as we're on that track, let's go ahead and continue with the cosecant. Okay. So the cosecant. Whoops.
Well, it's the same.
Cosecant x is equal to 1 over sine x, right? So whenever sine x is equal to 0, I'm going to get an asymptote. So I'm going to go like this, and there's one here, I'm not going to draw it over again, the axis, right? Go like this, and we're going to do the same exact thing we did before, where it's 1, it's going to be 1, -1, -1, 1, 1, and by the same way we talked about, we're going to look like really kind of a boring graph, right?
Yes, so more.
Cosecant and secant. Again, the period is what? 2 pi from here to here, 2 pi, here to here, 2 pi, 2 pi. Okay. So that's that. Let's see if we can do example number 3 and example number 4. Example number 3 says, find the value of x between pi and 3 pi over 2 that solves that. So I'm trying to solve secant x is equal to -2. Okay, so which means that cosine x is equal to
-2.
-1/2, right? -1/2. So, but I'm looking for the value between pi and 3 pi over 2, which is which quadrant?
The second. The third.
the third quadrant, right? Pi to-
Oh, pi.
Because it's 180 to 270, right? 180 to 270, correct? Like that. We'll ask the person who had the unit circle just click. So what is that?
Okay, so, what was the question?
So now I need to figure this out. It's going to be in the third quadrant, right? I know it's going to be in the third quadrant somewhere. So at what point is the cosine going to be -1/2? Cosine was X or Y? Cosine was X, right? Cosine was X, so -1/2, right? So I'm looking for this from here to here, right?
It's not. Well, I guess I give up on.
So 4 pi over 3, 240 degrees, right?
Yes.
Okay, everybody see how I work that out? Okay,
Looks like didn't click after
so
that.
that's that. Example number 4, find the smallest positive number x such that x squared is equal to cosecant x. So x squared is going to be equal to cosecant x. So example number 4,
Strong.
yes.
Why were they making triangles?
Why was who making
For
what?
example, 3.
Example,
If you
no,
go back.
there's no need to. Don't worry about it. Okay, so how am I going to solve this?
I can tell you.
So this is going to be equal to 1 over sine x, right? 1 over sine x. And we'll learn nothing that ties these two together.
Are you seeing where they meet?
You just graph it. You trace to find out where they meet.
Or that's pretty easy.
Pretty boring.
Um,
Okay,
don't have to really.
okay, and that's what they're going to do. All right, we're done. We are done for the day.
Number 9.